So we have the orange team, correct? Is that right?
Yes.
Okay,
Yeah.
when you're ready, fire away.
Good morning. We would like to present to you today our product, Quick Test. There are currently 2.6 million people in the UK with stage 3 to 5 chronic kidney disease. This is costing the NHS £1.45 billion per year. And it is likely to increase to 4.2 million people by 2032. And this is therefore going to increase the cost on the NHS. If you have chronic kidney disease, you are 16 times more likely to develop cardiovascular disease, and this costs the NHS an extra £1.1 billion per year. Now, fluctuations in blood potassium levels can cause these arrhythmias. Now, these blood tests are needed to detect these, and high potassium levels can be dangerous. So what is the problem? Well, blood tests currently are conducted through lab analysis or using a blood gas machine, but neither of these are portable or immediate, and this costs the NHS £6 to do a blood test. So how can we then help? Well, we could produce a portable and cheap test. This would allow us to closely monitor blood potassium levels and therefore reduce cardiac incidents.
So we are using a compound called valinomycin, which is the crazy looking thing in the corner. It's a naturally occurring potassium transporter. Its pore size is specific to potassium, which makes it ideal for putting into our test strip electrodes. The idea being that binding of potassium in blood will form a membrane potential which can allow us to detect the levels of potassium in the blood. So we've developed our test strip electrodes, which you can see on the left-hand side. So when a finger is pricked and you can put blood on the strip, potassium binds with valinomycin, and you apply a voltage between the working electrode, which is the one on the bottom, and a reference electrode, which is the L-shaped one, and measure the current between them, and then using a chip inside our little portable machine, this can be converted to a blood potassium reading, which gives an accurate readout of the potassium level in someone's blood. And knowing this, patients, for example, using this, you can see if the blood level was too high, and therefore if cardiovascular checks needed to be done.
So this would give us an advantage in that it's cheaper. It could work out to be cheaper than a full blood test. It could also be used at hospitals as well as at home. So somebody that knew they were at risk could get this product and then potentially use it to monitor themselves rather than going for a blood test that they may not get results back for a day or so. So again, quick and accurate results. And then it would save the NHS money because they'd be spending a lot less money dealing with patients that have got complications due to high potassium levels. So, as I mentioned, the NHS would be extremely important. They'd be our initial revenue stream, we think. So initially we want doctors to use this product. But there is the possibility of expanding so that it could be used in the home. Obviously that would require some development because you need to make it much more user-friendly, and you need to ensure that the patient would know what to do with the numbers that they were getting back. So whether they were in immediate danger or they were within normal levels, you need to educate the users a little bit. So what do we have already? We've got a basic prototype. However, we need to develop again a user-friendly casing and display for this product, sort of similar to what would be used for a blood glucose check, so a fingerprint test for that. And we have a patent pending that we've applied for through the University of Sheffield, and we've consulted an engineer and a manufacturer that would be prepared to get on board with this product. So in terms of a business plan, years 1 and 2 would really be a lot of product development and obtaining funding. By the end of year 2, that's when we envision we'd be selling this product to the NHS. Year 3 would be looking to expand to the EU and start developing the product for home use, as mentioned, and then by year 5 we'd be looking to expand internationally to the US market. So, into the finance side of things.
Okay. So, as a novel method for monitoring the potential for a cardiac event, our device should corner the market. So once completed, our product will be the most efficient, effective, and only immediate method of measuring your blood potassium levels. We expect, therefore, to minimum recoup our investment, but we hope to further license our product into other countries. To recoup the investment in our company, at minimum, we would need to sell 100,000 quick test monitors. This only represents 1/26 of the current sufferers of chronic kidney disease in the UK alone. There is a potential market of 2.6 million in the UK and 20 million in the US. So, a potassium meter with a minimum lifetime of 1 year should cost around £7 to make, based on estimates from blood glucose monitors. So that's roughly £4 for manufacturing and £3 for materials. Based on similar products in the market for blood glucose monitors, each unit is roughly priced at £15, although the price ranges from 15 to 50. At a very reasonable price of £20 and in a unique position on the market, we would expect to sell the minimum number, 100,000, quite easily. We have estimated our yearly sales based on reaching out to 1/10 of the sufferers in the UK in the first year of sales, which would be our second year of business. Then we would move up to 1/4 of people in the UK who suffer from chronic kidney disease, up until a half by the third year of sales. We would hope that in the third year of sales we have accrued enough interest from the NHS that we'll be able to distribute to GPs and to individual hospitals. So I've included low estimates for 1 unit per GP into our year 3 sales. Also included some rough ideas of what we might expect to make in the US, where the market will be 20 million. And I've included an estimate for 1/100th of the people who suffer from severe chronic kidney disease buying a meter in the US at the lowest possible price, which would be £20. So we would like to mitigate the cost of manufacture, which will be our largest costs, considering the fact that we have an almost working prototype. And we would do this using NHS funding streams for in vitro diagnostics. So the main one that we are eligible for is Invention for Innovation. Because we are aiming to use a cheap, widely available meter in collaboration with the NHS, which can be used in hospitals and to reduce the number of people going into hospital, and we have a proof of concept prototype, we are eligible, once we have an industry partner, to apply for much more funding through the NHS. So the next annual call for this is actually beginning today, and if we apply early, we're likely to get funding, or at least a measure of whether we can get funding or how much we might be able to get within 6 months.
So how can you invest in our business? Well, we are asking for £700,000 in exchange for a 15% share in the company, and that would allow us to complete our prototype production and testing in our first year. And like we said, in collaboration with industrial partners, and it will help us to mitigate our manufacturing costs, and also with the NHS scheme. We've also included an exit value, and that was predicted using the Gordon growth model, and was made conservative. So please invest in our business. Thank you.
Nice, short, direct presentation. Very good. Nice spreadsheet. So we have lots of time for questions. I see a couple of dragons just doing their capital employed calculations on the back of their head. Whatever happened to their arithmetic? Claire, do you want to start?
Yes, I can do. Yeah, I like the idea, but I think the major problem you've got is it's going to cost quite a bit more than the
still got the problem of someone's got to approve the spend of something that's costing more. There's something that, have you thought about how you might market it?
Sorry. Yeah.
And for a blood test that you do privately, it's £40 at the moment with a 1-day turnaround.
You mentioned
£6 in your slide.
In the NHS, yeah, for them to do an individual test. For an individual test, once you bought the machine, it would be 21 pence to use our machine. So if you were to buy the machine at home, it would cost you £15 to start up, which initially is already a third of the price of doing your own home test online. And within the NHS, instead of £6 per test for staff, it would be 21 pence per removable strip.
Right, so you've got, so you need them to buy the capital equipment, and then you're going to have your constant revenue stream of disposables.
Yeah.
Okay, there's just different ways of, for a hospital to be able to buy capital equipment, there's a different process they have to go through that. So, and without that, they can't.
Well, it would be £20 per machine. So in the estimate, I have included roughly, I think, 5 per hospital. So from my understanding of it, an initial budget of £100 for the outlay would be worth it to the hospital to remove the number of lab analysis that's going through. Because at the moment it has to be individual lab analysis, which takes a day and it takes staffing as well. So this would reduce not only the cost of probably the materials, but also reduce people having to be involved at all, except for the person reading it out and then describing to the patient what that outcome is.
Right, okay. And then you did actually touch on it briefly about the home unit, because obviously what's the patient going to do with that data? So how have you thought about how might you develop it? Is it going to be a safe, you're not safe? Because does someone have to analyse an actual readout figure and then decide what to do with that?
So I think for a home use device, what we were thinking is that it would be a sort of safe, not safe. So if you're in real danger, you need to go and see your GP.
Right.
But we were thinking for people that it'd be more for people that are at high risk that needed to take tests quite regularly. So yeah.
I would assume from that then that if you wanted to use it regularly to monitor a very serious condition, that you could go to your GP the first time, look at the reading, establish what is your baseline level and what they would consider to be dangerous, and then keep a record of that, so that whenever you use it, you can tell yourself if it's above a certain number that you're in trouble, as people do with the blood glucose. Thank you.
Like my colleague, I wanted to explore cost a bit more. I'll probably gloss over that. I like the way that you did make a point about this isn't just about consumable cost, it's about opportunity cost and time. I think I'd like to see that worked up a little bit more, but at least recognise it. That's good, I think. You mentioned, I think, 3 things in your slide, which was current state of the art in hospital is not portable, not immediate, and costs £6 a test. Let's pass over the cost part and focus on the not portable and not immediate. Intrinsically, that sounds really good to me. So you've spoken with clinicians, I assume, in some depth, and they've fed back to you that not portable and not immediate is a big problem for them, and they bite your hand off. Would you expand on that and what the evidence they've given you for that?
Yeah, so I've chatted to a few doctors who are currently working within the NHS about this idea. And the main problem is that potassium levels can fluctuate really quickly, and actually even a small spike to a very high level can be really dangerous in terms of cardiac events for a patient. So having a really quick test that would give you an immediate indication of the blood potassium level of a patient, rather than doing sort of a current blood test and either sending it to a lab where you get the results the next day, or using a blood gas machine, which can be sort of a few minutes before you get a result. Actually having an immediate one would be really useful and a really good indicator of actually what is going on and what the best course of action and treatment is for that patient at that time.
Cool, thank you. So clinicians have confirmed benefit, that's good. What about people who pay for it? What about some of the NHS, have they confirmed the kind of benefits you're talking about? You've given some numbers about the size and cost of the problem. Have you had some feedback on that?
Not yet.
Okay. Right. One last question, and again, is there any chance to go back to your first slide, the one that's got the technology on it?
That's
That one, oh, sorry, the one with the blob, that thing, thank you.
that thing.
Right, cool. So just quickly again, tell me what your intellectual property is about. You filed a patent. In real brief summary, what's the claim 1 in the patent about? What's it on?
So it's on the electrodes. So it's using, so valinomycin is well known to bind to potassium and is used in kind of larger scale.
Can't patent that then, is that right?
Yeah, so we
Great.
can't patent that, but what we can patent is the combination of the valinomycin and the electrode in the strip to go in the
Okay.
machine.
I probably as an investor want to kick the tyres a bit more, because I guessed you'd say that you can't pattern. So I think of biosensors like having two components, a transducer, which in your case is the electrochemical part, and the bioreceptor. As you say, it's the combination of the two. You haven't got IP on the bioreceptor, and on the electrochemical part, as you've articulated, there are some really big companies who've spent an awful lot of money on research, and they own the blood glucose monitoring market. I'm wondering if they might have a competitive advantage over you.
Possibly.
It's something you've thought about, I guess.
Yeah, it's absolutely something that we've thought about. I think the fact that it's not on the market means that there must have been some failures during initial testing, but our data that we have from our proof of concept, testing different people's blood and also artificially changed levels of potassium, shows that we can, as well as any conventional method, measure the level of potassium. So exactly why it hasn't succeeded before is unclear, but the science is definitely working.
So I
and
think
there's a need
you've
for it.
answered my question about what's on the market now, maybe also some more horizon scanning about what's going on, maybe. Thank you.
So you mentioned fluctuations in potassium level are a real issue. How quickly are these fluctuations?
As far as I understand from talking to sort of people in the know, actually they can change sort of very rapidly, possibly sort of like a few, I don't know, maybe hourly or something along that scale. So it's certainly quickly, so that sort of a lab test that gives you results the next day is sort of too long by a long way.
Fluctuations can also happen when you're taking the blood test as well. If you tense up when, say, nervous or something from taking the blood test, these can alter the figures that will come out at the end of the blood test.
Yeah, I was just thinking with the at-risk patients, if it's like hourly monitoring, so you've increased your market quite quickly, haven't you? Also, I would consider adding a Wi-Fi option or a USB link. Then, if people are using them at home, that data can then transmit straight away to that district nurse or GP.
Yeah.
Yeah.
Or even in the hospital, because the NHS digital is now wanting to move everybody onto electronic care record by 2020. If that could feed straight into that, and then the doctor or consultant straight away has those numbers in front of them.
That would be
Yeah, because the prototype at the minute is the strip and the ability to test, so we need that sort of information to design the actual casing and how the software would work. So something like that is something that we'd look into.
Looking at what's on the market right now, there are smartphone pluggable glucose meters, but they're about roughly £10 more expensive for pretty much the same software and pretty much the same everything. There's quite a high markup on that, so I think if we were to sell that within the NHS, they probably would want us to cut that cost down, regardless of whether it had extra sort of capabilities. I think that they would, because depending on whether we were using the I4I funding scheme, because if we were using an NHS funding scheme, I think they would want us to cut the cost per unit down to as low as we possibly could.
We could also include that in the home one.
Yeah.
So we could have a separate one for the NHS that might not need this. So we could keep the cost down for the NHS, but then we could add that to the one for home.
Okay, any more difficult questions?